Hello developers, let's start developing. My name is Veko and the World Cup finals is over. Argentina won, good luck to them. So we can now focus on the advent of code. I missed the day 16 and 17 so far. I actually tried to solve day 16, but I failed miserably because I focused on the wrong thing. I will talk about it in the relevant video when I upload it. But let's take a look at day 18, which is the current day. So we solved the elephant that we actually met in task 16. We brought them to fresh air, and now something is falling out of the volcano, and we are scanning it with some kind of a weird device, and it gives us 3D coordinates. And we are giving 3D coordinates of the droplets, and we need to see if they were cubes, how many sides we would see. For example, if our cubes are here and here, we would, and each cube has 6 sides normally. That means that they are touching on one side, so that side of both of those boxes droplets will not be seen. So we will have 5 sides each, or a total surface area of 10 sides. And in this task, we just need to count all the sides, so to say. Parsing the input seems relatively straightforward. We are just giving 3 positive numbers. So we can just say, read the lines, and then return lines.map. Well, for each line, we're just gonna need to split it on a comma. Yeah, that's all there is. And then map it to the number constructor. Or we can either say, yeah, let's do parsing. For each part or coordinate, we need to do parsing for the part. And in JavaScript, it's always smart to do to add a radix, so we don't get any weird things. And these are the coordinates. And actually, we can just return them. We can have some kind of an interface. Let's do that. Called point, which will have an X and a Y and a Z. And we can just return. Yep, the first coordinate is X, the second one is Y, the third one is Z, and we just do that. So this returns a array of points. So it's not a string array that we're doing, it's a point array. Change that. Let's see if it works by logging the input. Do we get our data? Yep, it seems we do. So now for the first part, we just need to see whether they are touching or not. So what I will do, I will create another array, droplets, which will be, should we do it like this? No, the droplets will be a map from a string to a number, and I will add a one thing. From a point, I will get a string, because I want that string, I want a map that will map from a droplet to the number of sides, its sides that are visible. Why do I do it this way with the string? Why do I do those kind of things? When if you have in JavaScript, if you have a map, that maps basically test the equality of its values. And if we have two strings, let's say a string called veco and a string called veco in JavaScript, it says that those are true. But if we have two objects, one object with the name property veco, and yet in one more object with the name property of veco, those two strings are false, are not equal. Those two objects are not equal. So in the same sense, if we have a property with x1 and another proper object with x1, those are not equal. Why? Because those are different objects in different places in memory. So we can mutate them independently. And they are not strictly equal. They have the same values, but they are not the same object. So in this thing we have reference equality, and in this uh, case we have value equality. And the map always uses value equality. So we will need to basically from our points make some kind of a string, because that's what this do. This takes a point and gives us a string. And we can also do will it guess? No. We might need this as well. Where we do this. We take a key that's a string and we are doing this, and now I'm seeing that that's exactly what we're doing in our parsing method. So we can just say to point line. Let's not repeat that part once more. So let's see once again whether this makes sense. Log the input, whether the parsing is processing as we want it. Yes, it does. So now I will just run through all of the droplets. And droplets dot add set. No, not a droplet of 0, but to key of droplet and 6. Why doesn't this work? Because a droplet, not of droplets of input. Yeah, a droplet is a point, and now from that point we are making a key and we are adding the value. So each of those droplets gets its numbers reduced. So yeah, the numbers are not actually reduced. Each one takes. Initially, we're saying that each of those droplets have 6 sides exposed. And now we will just need to see whether there are some pairs. So for each pair of droplets, we will check whether they are touching. If they are touching, we just reduce them, reduce their number of sides. How do we do that? Well, a simple for loop. Yeah, let's use I this time because I'm gonna want to have a nested for loop. Less than input.length This is the first one. And loop once more. Take the second one. And this will loop through all of the pairs of droplets. We can check whether they are pairwise. Yeah, pairwise connected. What connected means? It means that they are either next to each other, or above each other, or in the third dimension, whatever that is. So to order to get that, we will get the distance, which is the distance on the x-axis and the distance on plus the distance on the y-axis plus the distance on the z-axis. So if they are on the same axis, they will have a difference of 0. And if they are next to each other on some axis, they will have a value of 1. What we want to check is that have the same they have two coordinates that are the same, and the third coordinate has a difference of 1, which means that this can only be 1, because two of these, we have three parts to this distance calculation, and we need two of them to be 0 and one to be exactly 1, which means that if distance is equal to 1, then something like this. Yeah, only we don't need this check. And I will move the getting of the first key to this, because otherwise we're just doing the same thing over and over and over again. And of course the first value as well. Do we need the first key once more? Yeah. On the other hand, we can avoid this double setting by doing something like this. So the value will have a size value, which is a number. So here we just won't enter a 6, we will just enter an object that has a size property, which is 6. So now we can do this. This is the first size. And that's droplets get this. We can do it on a single line. So we're getting the first size parameter, and similarly we will get the second size parameter. And that's 2 key of second. And now we don't need to do a set, we can just say remove aside from the first and remove aside from the second. Let's see what we got from the droplets. So this 2, 2, 2 is beset on all sides apparently. Do we have 1, 2, 2? Yes. Do we have 3, 2, 2? Yes. Do we have 2, 1, 2? Yes. 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 And you can see that all of these are, so we have a box, and on all of its sides we have other boxes. So 0 total sides are exposed. Let's sum this up. Let's just get the values and map that, and then we can just call the sum method that we already have. It's just the same. Why is it complaining? This is an iterable iterator, but means that we can make an array out of it. And then we just say, actually we can avoid the mapping because some can map as well. We just need to say, well, for each droplet, take its size and sum on that. Let's try to return that number. Yeah, this is not a great algorithm. This basically has quadratic complexity because we're generating each pair of droplets. Result part 1 is 64. Okay, that's what we wanted. I think so. Yes. So let's take the big input, which has more like 2000 items, and see how long this takes. I don't think we have negative numbers here. It says the minus sign is not met, and we are getting 3576. Let's see if that is the correct number. That is the right answer. We have our 31st gold star. Let's see what part 2 is. And just a note that as these tasks are getting more and more hard, which means that we will need more and more time to solve them, and I'm not magic, I do fail occasionally. This means that from now onwards, for the harder tasks, I will try to solve them offline and then kind of reiterate the solution online. And most of them will have a separate part 1 and part 2 in order to avoid any 5-hour long live coding sessions, which are not fun for anybody, including me. Let's see. Something seems off about your calculation. The cooling rate depends on exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sites that could be reached by the water and steam. As the lava droplet tumbles into the pond, the steam will expand to reach as much as possible, completely displacing any air of the outside of the lava droplet but never expanding diagonally. Aha. Aha. So 225. Yeah. We need to calculate the exterior surface area. And this is weird. This is gonna be harder, much, much harder. What is the task? You can see that we have these four. 2 to 1, 2 to 3, 2 to 4, 2 to 6. Let's draw them out in some Excel. So we have 1 through 3, 4, 6. On the 2 to side, yeah, we have 4 and we have 6 over here. So this is the 2 to. Let's say this is x equal 2 plane. And we have 2 to 4 and 2 to 6. Now let's take this as the 2. This is x equal 2 plane. So this is y and this is y and this is z. which means 4 and 6 are these two. And it also means that, yeah, 2, 4 and 2, 6. And then we have 1, 5, which is this one. And then we have 3, 5, which is this one. And then we have 2, 5, which is this one, but one toward the screen and one away from the screen. So this means that there is no cube on the 2, 2, 5 location. There is a pocket of air. But the other thing is that air reachable? No, because in order to reach that air, we actually want to have some kind of a way to get out. And this cannot, because this is a cube of air that is covered on 6 sides by uh, just cubes, droplets. Yeah, so this means that we will need to find a way to detect if when we process all the droplets, if some side of the droplets is somehow enclosed, and if it is, then we don't need to count it. So it's just the same as this 222 thing. Only 222 is already a droplet. If we had these 6 values and we didn't have this one, this would have meant that this area is not accessible in any way, shape, or form. But I will do some thinking and then we will have a separate video where we are discussing that. In the meantime, don't forget to like and subscribe, and we will see each other again when we're actually solving part 2.